Hi, my name is Reza Taimuri and welcome to STS School. In this video, we'll learn how to find the correct UTM zone for your raster data and how to reproject it properly. To demonstrate this, I have prepared a terrain raster that uses a geographic coordinate reference system, WGS84. We're going to find its appropriate UTM zone and reproject it. The first step is to add the raster to the map. To do this in STGIS, simply right-click on the Layer panel, choose Add Layer, and then select Add Raster. Simply select your raster file. As you can see, the raster is now added to the map, and its coordinate reference system is geographic, which uses degree as units. However, as you know, for performing calculation on terrain data, we need a projected CRS that uses SI units, in this case meters. So we need to reproject this raster to a projected coordinate reference system. To find the appropriate UTM zone, we have developed a tool that automatically detects the suitable zone based on the map's coordinates. To open this tool, you can either right-click on the raster layer, go to Layer CRS and select Find Projected Coordinate Reference System, or simply go to the Tools tab and click on the tool from there. Inside this tool, simply select your target raster and the appropriate UTM zone will be displayed automatically. To reproject the layer, just copy the suggested CRS code and go to the Warp tool under the Raster tab. This tool allows you to reproject, resample, crop, and compress rasters. Simply paste the CRS code into the target CRS box. And now we can click on Compute to compute the raster, or if we don't want to save it temporarily, we can select the Browse to save the file on disk and then click on the Compute to compute the raster. As you can see, the raster has been correctly reprojected to UTM zone 16 north. To change the project CRS and focus on the layer, simply right-click on the layer and select Zoom to Layer. You can inspect raster cell values using the Identify tool and Layer Values tab. To return to the original geographic raster, simply right-click the layer and select Zoom to Layer. You can modify raster display settings by right-clicking the layer and adjusting the symbology options. As a matter of fact, if the CRS is not projected and the units are not in meters, the hillshade would be distorted, and that is a sign of working on wrong CRS in STGIS. Let's return to our projected layer and examine how the hillshade performs for it. As you can see, the hillshade is functioning correctly and the layer aligns perfectly with the tiles. This confirms that we have successfully reprojected the layer. Let's select the terrain preset symbology among the preset symbology options we've provided for easy visualization of different raster types. You can fully customize raster symbology by applying different color schemes or creating your own. Adjust the parameters to find the optimal visualization for your data. There are two raster rendering modes in STGIS. The first one only uses a color scheme to show values, but the second one, while still using colors, overlays a hillshade layer to show the high grounds and low grounds of terrain. The transparency of both the color layer and heat shield layer is adjustable. You can save your symbology settings to a file for reuse with other rasters. Additionally, you can directly copy and paste symbology between raster layers. I hope you enjoyed this video. We're just getting started, and our goal is to create tutorials that begin with the simplest yet important features and gradually move on to more advanced topics. If you'd like to learn more about STE and how to use it in your projects, make sure to subscribe to our YouTube channel. Thank you for your interest in STE, and I hope you enjoy working with it. Goodbye!